So if it's not the experiment, and if it's not the mind, what is causing the wave function to break down in the double slit experiment? The answer to that is quantum mechanics. It's the way quantum mechanics work. Quantum phenomena are in part probabilistic. And when something quantum is in a superposition, it is in both of those probabilistic states at the same time, unless we force it to do otherwise. So I'm going to explain this to you in the only way I know how, a very shitty MS Paint drawing. I'm going to start by drawing a shitty photon. Shitty photon. Now I'm going to draw our shitty slits with shitty detectors. Genuine work of art. Now let's say that the detectors are off. The photon acts like a wave, so it just keeps going like this. And you'll notice something. It's gone through both slits because it was waving up and down through them. It could go through both slits, so it did go through both slits. But now let's say the detectors are on. Now it can only go through one slit. So our buddy photon either hits this slit, and when it comes out of the slit it looks like this, or it hits this slit, and when it comes out of the detector it looks like this. It has nothing to do with us seeing the wave, nothing to do with our mind. It has everything to do with the probability of what this photon can do. If we make it so that this photon can travel through both detectors, then it will travel through both detectors. But if we make it so that it only travels through one, then it will only travel through one. Which means the interference pattern breaks down, and we could only detect it at one of two spaces. That's really what we're doing. We're restricting probability. We're making it so that the photon can no longer be in a superposition. It has to go down one slit or another. Restrict that probability, and you lose the interference pattern. Don't restrict that probability, and it ends up going through both slits at once. We basically make it flip-flop from wave behavior to particle behavior. And again, I'm going to explain that with my shitty MS Paint graph. Remember the uncertainty principle, where you could only know how fast something is moving or where it's going? Well, here, you see exactly where it's going. You know it's going to hit at the red spot. But you no longer see the wave, so you have no idea how fast it's going. Same thing goes for here. You know it's going to hit the green spot, but you don't know how fast it's going because you can no longer see the waveform. But over here, you know exactly how fast it's going. You see its frequency and amplitude, but it could hit either of the spots. And that is the quantum mechanism. If something in a superposition has to be in one of two states, it will collapse and be in one of those two states. But if it doesn't, then it will be in both of those states at the same time. It's about what it can do, not what we do to it.